Windsurf just accomplished what every major AI company failed to achieve. They built the first artificial intelligence system that actually understands how real software engineering works. While ChatGPT and Claude give you isolated code snippets, SWE1 maintains awareness of your entire project timeline and workflow context across weeks of development. This represents a fundamental paradigm shift from retrofitted general-purpose models to purpose-built engineering intelligence. The implications are so significant that OpenAI is reportedly preparing a $3 billion acquisition to integrate SWE1 into their ecosystem. Today, I will examine how SWE1 transforms software development from isolated assistance to embedded workflow intelligence that could revolutionize the entire engineering profession. Current general-purpose models like GPT-4, Claude, and Gemini excel at generating boilerplate code and providing debugging assistance, but they fundamentally misunderstand how software engineering actually operates in professional environments. Real developers do not write isolated functions in a vacuum. They navigate complex workflows involving incomplete tasks, cross-team collaboration, comprehensive code reviews, legacy system debugging, and long-term dependency tracking. The development process is inherently dynamic and fragmented, requiring sustained context awareness that general models lose within minutes. Existing AI tools were retrofitted for engineering applications, rather than being designed from the ground up to understand software development workflows. This architectural limitation creates a ceiling on their effectiveness in real-world engineering environments. Windsurf recognized that sequential decision-making and long-term context retention are fundamentally different challenges than simple code prediction. Their solution required building entirely new training methodologies focused on capturing the complete software development lifecycle rather than just syntax patterns. SWE1 employs a sophisticated three-model architecture designed to address different complexity levels within software engineering workflows. The flagship SWE1 model handles high-level reasoning, tool integration, and multi-step workflows, including comprehensive code reviews, architectural planning, and system integration tasks. SWE Lite manages immediate development needs such as inline suggestions, refactoring assistance, and lightweight code completion for both free and paid users. SWE Mini powers continuous passive predictions within development interfaces, providing unobtrusive support without requiring explicit prompts from developers. The breakthrough innovation centers on flow awareness, where SWE1 maintains understanding of task positioning within broader developer workflows. This creates a shared timeline between the developer and the artificial intelligence system, enabling the model to track project context evolution and recognize how early decisions impact subsequent development phases. This contextual awareness allows SWE1 to support activities beyond code generation, including identifying inconsistencies during refactoring processes and suggesting architectural modifications based on established patterns. The system retains awareness across extended development sessions, making it particularly effective for enterprise environments with complex, iterative development cycles. SWE1 functions as a collaborative system rather than a traditional autocomplete mechanism. The architecture embeds within version control systems, code editors, and collaborative development tools to provide continuous assistance rather than reactive responses to specific prompts. The system operates without requiring explicit user requests, maintaining awareness of development progress and providing contextual support based on current workflow status. Current integrations include Windsurf's browser-based integrated development interface, Visual Studio Code, and Git workflow management, with planned expansions to issue tracking systems and continuous integration pipelines. This embedded approach positions SWE1 as a workflow participant rather than an external tool. The system mimics how professional software teams operate in practice, focusing on sustained collaboration over time with emphasis on predictability, low latency response, and contextual relevance within software development environments. Windsurf designed SWE1 to excel in engineering-specific performance metrics rather than competing directly with general-purpose foundation models. The focus centers on multi-step debugging processes, code maintenance recommendations, and long context reasoning within engineering workflows, where specialized performance matters more than broad capability demonstrations. Multiple credible industry sources report that OpenAI is pursuing a potential $3 billion acquisition of Windsurf, though official confirmation remains pending. This acquisition would provide SWE1 with substantially expanded resources, including enhanced computational capacity, advanced agent research capabilities, and sophisticated training pipeline infrastructure. The strategic alignment supports OpenAI's broader initiative to develop verticalized artificial intelligence models tailored for specific professional domains. SWE1's comprehensive approach to software engineering workflows fits directly into this strategic direction, potentially accelerating both development timelines and capability expansion. This acquisition could represent a pivotal moment in professional software development, marking the transition from isolated code generation tools to embedded systems supporting the complete engineering lifecycle. The integration would enable tighter coupling with OpenAI's existing platform ecosystem while maintaining SWE1's specialized engineering focus. If you liked the video, don't forget to press the like button, comment, and subscribe to the channel. The emergence of domain-native artificial intelligence systems like SWE1 suggests a fundamental shift towards specialized models that outperform generalist approaches in sustained, high-context professional tasks. This represents movement beyond surface-level productivity improvements toward deeply embedded systems that understand professional workflows at granular levels. SWE1 represents the emergence of artificial intelligence systems designed as participants in complete professional workflows, rather than reactive tools for isolated tasks. This workflow-aware approach treats artificial intelligence as a collaborative partner aware of historical context, future requirements, and appropriate automation opportunities. The potential OpenAI acquisition signals recognition that specialized, domain-focused artificial intelligence models may represent the next major advancement in professional software development tools. This could accelerate the adoption of workflow-centric artificial intelligence approaches across the software engineering industry. We are witnessing the transition from surface-level coding assistance to comprehensive workflow intelligence that understands the complete software development lifecycle. The question facing engineering teams is whether they will adapt to collaborative artificial intelligence systems or risk competitive disadvantage against organizations that embrace embedded workflow automation. The software engineering profession stands at the threshold of fundamental transformation, and SWE1 provides our first glimpse of what professionally native artificial intelligence systems can accomplish when designed specifically for complex, iterative workflows rather than simple task completion.